All right, most of you should already have your 5.1 to 5.3 quiz review. I think that's a really good opportunity for all of us to just go and look back at what we've done in 5.1 and 5.3. This is the warm-up you would have got with those slides on that. I'm going to use it more as a lesson. We're going to talk a little bit more about everything that's on this slide than what's already there. But I hope it's helpful for you guys when completing 5.1 and 5.3. All right, so it says using composition, prove that g of x is the inverse of f of x. And so we know that composition is f of g of x or f of g of x, like this, where g of x is my input to f. And we can see that g of x is x squared plus 1. So this is really f of x squared plus 1. And what does that equal? So we're going to take that x squared plus 1. We're going to plug it into f of x wherever we see x. And if this is the actual inverse, if g is the inverse of f, then what we should get is the value of x. So I have the square root, and now I'm going to put x squared plus 1. That's for this x here, and then I'm going to put minus 1. All right, so then I just get square root of x squared. Well, what is the square root of x squared? We know that a square root undoes a square, so we get just x. And so yes, we have verified that x squared plus 1 is the inverse of x minus 1, square root of x minus 1. I want to take it one step further and talk a little bit about domains and ranges. So they've already found the inverse for us, but when we find the domain and range of our original function, that should be the domain and range of our inverse. So let's find the domain and range of f of x first. So my domain for f of x has to be everything greater than 1, because I can't take the square root of a negative. All right? The range is a little bit harder to find, but it has to do with the graph, or if I plug 1 in for x. So if 1 is my minimum value for x, if I plug 1 in here, what's 1 minus 1? What's 0? What's the square root of 0? It's 0. So my range is 0 to infinity. Another reason is this graph is a square root function that moved right 1. It didn't move up or down, it moved right 1. So I can see my domain is everything greater than or equal to 1, and my range is everything greater than or equal to 0. So I don't even need to think now for what my domain and range are for g of x. I'm just going to simply reverse them, because when I find the inverse, my x and y and my domain and range flip. So my new domain is 0 to infinity, and my inverse range is going to be 1 to infinity. This makes sense to me because this is a parabola moved up 1, so that's going to give me that range. What might not make sense to you is a parabola normally has a domain of all real numbers. This one does not, because it's just an inverse. And remember, the inverse is a graph that's reflected over y equals x. And so we would only see half of our quadratic on that. So this is the correct domain and range for this. All right? Moving on to exponential equations and solving. Remember, we had the uniqueness property, and so we want to make 1/2 and 8 have similar bases. So I'm going to say base 2 is something that 1/2 and 8 both have in common. So instead of 1/2, I'm going to write this as 2 to the negative 1, because I know that is equivalent to 1/2. All right, so this really becomes 2 to the negative 1 all to the x plus 3. And then if I want to write 8 as base 2, it's going to be 2 to the 3rd power. this point, I can distribute that negative to both of those. So 2 to the negative x minus 3 equals 2 cubed. Once your bases are the same, the uniqueness property says I can set my exponents equal to each other and solve. So I'm going to add 3 to both sides. Negative x equals 6, so x equals negative 6. That's our answer there. All right, remember, if you have any questions, you're going to want to either just Google message me through Google Classroom or Remind or email. Just let me know what questions you might have. All right, last but not least, probably your least favorite thing, I just want to make a clarification of this. I couldn't make it do a sub 2 on this, so this is y equals log base 2 of x. And so remember, our steps with graphing logs is 1, we want to graph exponential function. So if I make a little table for that, I get x and y. Just put in a couple values here. This is for y equals 2 to the x. Oops, sorry, 2 to the x. So 1/4, 1/2, 1, 2, and 4. I want to graph that. So that really, to graph like my important numbers, it's going to be 0 and 1, 1 and 2, 2 and 4. So here's my exponential function. I know that my points for the log are inverse, and so my x and y's are just going to flip. So I have 1/4, -2, 1/2, -1, 1, 0, 2, 1. Down here's 4, 2. Sorry, I ran out. Again, I'm going to kind of start with my nicer points. So over 1, over half, down -1, over 1, 0, over 2, up 1, and then I'm going to be over 4, up 2. And there's my log, base 2 of x. All right. I do want you guys to be working on at least page 1 of your 5.1 to 5.3 review sheet. Page 1 will be due Monday. The rest of the review worksheet will be due Tuesday. I will put this in Google Classroom. Thanks for your time.